Dear students, under the topic angle of intersection of two curves under polar coordinates, here we have the third problem. Find the angle of intersection of the curves r equals a sine 2 theta and r equals a cos 2 theta. So as the first step, let us consider the first curve, that is r equal to a sine 2 theta, and let us mark this as equation 1. Now, in order to find the angle between these two curves, we have to find xi, which is equal to phi 1 minus phi 2, where phi 1 is the angle between the radius vector and the tangent at the point of intersection for the curve 1, and phi 2 is the angle between the radius vector and the tangent at the point of intersection for the curve 2, that is this curve. So when we subtract this and when we take the absolute value, we get the angle of intersection of these two curves. So as the first step, let us mark r equal to a sine 2 theta as equation 1, and let us differentiate this equation with respect to theta. So when we do so, we get dr by d theta to be equal to a is a constant multiplied with the differentiation of sine theta, which is, because we have sine 2 theta here, its differentiation will be cos 2 theta multiplied with the constant, that is 2. So this is dr by d theta. So next we have to find tan phi, which is that is tan phi 1, because we are doing for the first curve. So tan phi 1 is equal to r multiplied with d theta by dr. So this can be rewritten as 2a cos 2 theta. Now this will be equal to, what is r? So from equation 1 we know that r is a multiplied with sine 2 theta multiplied with d theta by dr, which is the reciprocal of dr by d theta. So the reciprocal of this will be 1 divided by 2a cos 2 theta. So if you see, a and a gets cancelled, and finally we get tan phi 1 to be equal to 1 by 2. What is sine 2 theta by cos 2 theta? It is tan 2 theta. So now we have to find the angle phi 1. But if here we have 1 by 2 tan 2 theta, if there was no constant over here, we can directly equate the angles. But we see that we have a constant 1 by 2 over here. So for that reason, we cannot equate the angle. So this problem will be dealt with a slight different manner. That is, we will have tan phi 1 as it is, and we will be using the formula tan, that is we want to find xi equal to phi 1 minus phi 2, for which we will take tan on both the sides. So tan xi will be equal to tan phi 1 minus tan phi 2. We will apply the formula for tan phi 1 minus tan phi 2, and in that formula we will substitute directly tan phi 1 and tan phi 2. So for that reason, let's not make any change over here. But for this tan 2 theta, we will be having a change. That is, from the given question, we have r equal to a sine 2 theta, and also r is equal to a cos 2 theta. So if we equate these two, what we will be getting? We will be getting a sine 2 theta is equal to a cos 2 theta, and when we cancel the a, we get sine 2 theta equal to cos 2 theta, and sine 2 theta divided by cos 2 theta will be equal to 1, and tan 2 theta will be equal to 1 thereby. So I will explain this at the end of the problem. So as of now, I have just given you the idea of the problem. So we will proceed the problem further. So this, let us not make any change as of now. So we will deal with it at the end of the problem. So you just have a mark of this, that is tan phi 1 is equal to 1 by 2 tan 2 theta. In a similar way, let us consider equation 2 now. So what is equation 2? The other curve, that is r equal to a cos 2 theta. So if we consider that r is equal to a cos 2 theta, and we shall mark this as equation 2. Now further we have to differentiate equation 2 with respect to theta. So when we do so, what we get is dr by d theta is equal to A is a constant, and what is the differentiation of cos 2 theta? It will be minus sin 2 theta multiplied by the differentiation of 2 theta, which is 2, the constant 2, because the differentiation of theta is 1. So therefore we get 2. And so therefore dr by d theta is equal to negative 2a, I am rewriting it, sin 2 theta. Now next, using this we have to find tan phi 2, which is given by r multiplied with d theta by dr. So what is r? Now here in this case we have considered r to be a cos 2 theta. So we have to substitute that a cos 2 theta multiplied with d theta by dr, which is the reciprocal of dr by d theta. So the reciprocal of this will be 1 divided by minus 2a sin 2 theta. So now if you see here, this a and a gets cancelled, and finally we get tan phi 2 to be equal to minus 1 by 2. And what is cos 2 theta divided by sin 2 theta? It is cot 2 theta. So this is what we have obtained. That is tan phi 2 is equal to minus 1 by 2 cot 2 theta. So this is tan phi 1. Let us mark this as equation 3. And this is tan phi 2, which we shall mark as equation 4. Now, after this, we shall take the given curves. That is, the first curve is r equal to a sin 2 theta. And the second curve is r equal to a cos 2 theta. So, because both are r, we can equate a sin 2 theta to be equal to a cos 2 theta. So, from equation 1 and 2, so from 1 and 2, we can equate a sin 2 theta is equal to a cos 2 theta, because both are r. Now in this a and a gets cancelled, and when this cos comes to the left hand side, it will be taken to the denominator. So sin 2 theta divided by cos 2 theta will be equal to 1. But what is sin 2 theta divided by cos 2 theta? It is tan 2 theta. So therefore the value of tan 2 theta is equal to 1. Now we have got the value of tan 2 theta. So from this we can also get the value of cot 2 theta. So what will be cot 2 theta equal to? 1 by tan 2 theta, which is equal to, so this will be equal to, what is tan 2 theta? It is 1. So 1 by 1. Therefore cot 2 theta will also be equal to 1. So we have obtained tan 2 theta and cot 2 theta equal to 1. Now we shall substitute tan 2 theta equal to 1 in equation 3. So here instead of tan 2 theta we will replace by 1. So what we will get? We are having tan phi 1 to be equal to 1 by 2 tan 2 theta. So this will be equal to 1 by 2 multiplied with, what is tan 2 theta? Just now we obtained it to be equal to 1. So 1 by 2 multiplied with 1 will be 1 by 2. So therefore we have got tan phi 1 to be equal to 1 by 2. So let us just mark this. So now the next one is tan phi 2, which is equal to minus 1 by 2 cot 2 theta, which is equal to minus 1 by 2 multiplied with, what is cot 2 theta? That also we have obtained just now to be equal to 1. So this will be equal to minus 1 by 2. So therefore we have tan phi 2 to be equal to minus 1 by 2. So these are the two values. So the next step will be, we have to find xi, that is the angle xi. We know that the angle xi is equal to phi 1 minus phi 2. Now in order to find this, we don't have phi 1 and phi 2 directly, but instead we have tan phi 1 and tan phi 2. For that reason, we are taking tan on both the sides of this. So from this, tan xi will be equal to tan of phi 1 minus phi 2. But by the trigonometric identity, we know that tan of a minus b is equal to tan A minus tan B the whole divided by 1 plus tan A multiplied with tan B. So this is the trigonometric identity. That we will be making use of over here. So this is the trigonometric identity. So when we apply this identity over here, what will this become as? So tan xi will be equal to, so instead of A we are having phi 1 and instead of B we are having phi 2. So it will be tan phi 1 minus tan phi 2 the whole divided by 1 plus tan phi 1 multiplied with tan phi 2. Now let us substitute each of the values. So this will be equal to, what is tan phi 1? Tan phi 1 is equal to 1 by 2 and tan phi 2 is equal to minus 1 by 2. So we will substitute that over here. So tan phi 1 is 1 by 2, this minus, and tan phi 2 is minus 1 by 2. So minus of minus 1 by 2 the whole divided by 1 plus tan phi 1 is 1 by 2 multiplied with tan phi 2 is minus 1 by 2. So in the numerator we will be having 1 by 2 minus into minus is plus 1 by 2 the whole divided by, in the denominator 1, this plus into minus will become minus and 1 by 2 multiplied with 1 by 2 will become 1 by 4. So this will be equal to, what is 1 by 2 plus 1 by 2? It is 1 divided by 1 minus 1 by 4. So let us take the LCM, which is 4. So 4 into 1, so 4 minus 1. That is equal to 1 divided by 4 minus 1 is 3. So 3 by 4. So denominator of the denominator will become the numerator. So 4 by 3. So therefore tan xi is equal to 4 by 3, and hence we need the angle xi only, because that is the angle of intersection of the two curves. So therefore the angle xi will be equal to, taking tan inverse on both the sides, we get tan inverse of, so xi will be equal to tan inverse of 4 by 3. So this is the solution, that is the angle between the two given curves. So hope you have understood this problem. Kindly follow the next video lecture for more problems on this topic. Thank you.